I want to do an example using chain rule in multivariable calculus to do a related rate problem. If you haven't already seen a video on chain rule, I would urge you to go back and watch how chain rule works in multivariable. Gravel is being dumped into a pile that resembles a right circular cone. As the gravel is being dumped on top, the height is decreasing at a rate of 1 foot per minute, while the radius is increasing at a rate of 1.7 feet per minute. Find the rate that the volume is changing when the height is 5 feet and the radius is 12 feet. So, in multivariable calculus, one of the great things is we don't have to worry about creating ratios like we did in single variable calculus to try and relate the radius and height to one another. These things are allowed to change at different rates. So what we do need to do is start with our formula, volume of a cone, so that we know volume is affected by two things, the radius and the height. And both of those things in this example are affected by time. Then we kind of follow a chain or a branch here of derivatives. We know how the volume, or we're going to figure out how the volume is changing with respect to r, and multiply that with how r is changing with respect to time. So just following this down and saying what's each derivative. Then we go the other way, and we say, well, how is volume affected by h, the height, and how is that affected by time? So dv dh and dh dt. We're going to add those together to give us an overall change in velocity. Now, one of the things to note that sometimes can make this a little bit tricky is we have been given rates already. The height is decreasing at a rate of 1 foot per minute. So dh dt, we can fill out. It's -1. Whereas dr dt is increasing at a rate of 1.7. So we know dr dt is positive 1.7. Now, these other derivatives we have to calculate. So the derivative of volume with respect to the radius, meaning radius is my variable and height is simply treated as a constant. So you bring the 2 out front, drop the power. We would have 2/3 pi RH. Now, the derivative of volume with respect to height, so height is our variable, and r is treated as a constant, would just be 1/3 pi r squared. And now we could simply substitute in a height of 5 and a radius of 12. So we would have 2/3 pi times 12 times 5 times 1.7 plus 1/3 pi times radius squared times -1. And that will give us the rate that the volume is changing. Again, this is a really slick way to do related rates using multivariable calculus and the chain rule. If this video helped, please like and subscribe for more math help.